morning students. We are doing maximum and minimum. So today I'll be sending you video and few notes, and tomorrow we'll discuss about all these things. Now what do you mean by maxima and minima values? So first of all we'll be doing values. So for that, suppose if a graph is like this and this is a point which is maximum. So this is a point C on x-axis, which is called point of maxima. This is called point of maxima, and this is called maximum value. Okay, so we have to think this. These graphs are already drawn on page number 220. So you can understand what exactly it is, right? Suppose same. If I am drawing this way, then this is the point of local minima. So here we can take this C is a point where it is local minima, and the minimum value will be this. So this is a minimum value. So you don't have to take this point as local minima and this point as local maxima. The point is C here. At this point it is local minima, at this point it is local maxima, and the maximum value is here and the minimum value is here. So these graphs are already drawn. For example, if I am taking an example as find the maximum and minimum values of f of x is equal to x square. X belongs to R. Now this is a polynomial function. You all know x square is a polynomial function, and the graph also you know it's a parabola. So the graph will be if x is 0, if x equals to 0 you get y is equal to 0, if x equals to 1 you get 1, if x equals to 2 you get 4, if x equals to minus 1 you get again 1, if x equals to minus 2 you again get 4. So this is the point at x equals to 0, you get a minimum value, but there is no maximum value because you don't know where it ends, right? So what if f(x) equals to x square and x belongs to R, the minimum value of f is 0. And the maximum value of f not possible. So no maximum value. No maximum value. So this way you have to do. Suppose if I am doing modulus x. What is the graph of modulus x? If my f of x equals to modulus x. So what is the graph of modulus x? It is this. Correct? This is modulus x. So again same, minimum value 0, no maximum value. So this way you can decide. So these graphs we have already done in grade 11. So you can do in that way. Now, there are few definitions written. Definition. You have to remember that definition. In that definition, it is written as definition. It is written as let f be real valued function. Real valued function. And C be an interior point. C is any interior point in the domain. In the domain of F. Then first C is called local maxima if for h greater than 0, f of c is greater than f of x. For all, this is a notation for all, x belongs to c minus h, c plus h. Now how we can show this? This can be shown as this way. Suppose this is my point C. So there is some here h greater than 0. There is some h greater here. So here it is c minus h. Here it is c plus h. So this is the interval given. So in that interval, if fc is greater than f of x, then local maxima. And the value of f of c is called local maximum value of f. Second, C is called point of local minima. Same, point of local minimum if same for h greater than 0, f of c is less than f of x. Same interval for all x belongs to c minus h comma c plus h. The same thing, but it will be curve will be lower down. So this will be curve. So this is point C. Here any point. Here any point. So that will be c minus h, c plus h. So same it is there. The value of f of c is called local minimum value of f. So this is what we can decide: local maximum value, local minimum value. And then after once you know this, we will be having first derivative test and second derivative test. So they are also very easy. So how to go about first derivative test? So you need to remember theorem number 3. Theorem number 3 you need to write in the notebook. First derivative test. And theorem number 4, second derivative test. Theorem number 4 will be second derivative test. These two are very important. Now using first derivative, how you get the maximum and minimum values? So we will discuss this tomorrow. For today, only this much. You need to write this in notebook. Okay. Thank you, students.